Hey Wanderers, if you've ever been in a plane, you might have noticed that the food is rather bland and there's no real enjoyment in eating the airplane food. Just like any other dish, it gets prepared in a kitchen by a chef. It then gets packaged and stored for later for passengers, flight attendants, and the pilot during a flight. So why does it taste so bad? This phenomenon has puzzled passengers, flight attendants, pilots, astronauts up in space, and even scientists. But we may have just stumbled upon the answer, or should I say answers. And it isn't because of bad cooking. In this video, we will look at all the reasons as to why airline food sucks. But before we do, we need to have a basic understanding of how we taste. Well, not literally. We'll leave that for the aliens. Welcome to Taste 101 for Dummies. How we taste. Wait, I'm not calling you guys dumb. You know what I mean. Here is a human tongue. If we look closely, we might notice that it's covered in bumps and ridges. As alien-like as it looks, these aren't random. They are a structure called taste papillae, and these taste papillae exist on our tongue to increase the surface area so the flavors in our food can be sensed more intensely. And it also houses our taste buds. But how do we actually taste? How do the chemicals in the food that we eat get interpreted into different flavors? Taste papillae contains hundreds to thousands of taste buds. These are the different types of taste papillae that we have. Fungiform papillae are the most common form. If you've ever eaten something hot, you might notice that the sides and the tip of your tongue are more sensitive. Fungiform papillae occupy the edges and the tip of our tongue, and they have sensory cells that are important for touch and temperature sensations. Now let's look at the very back of this tongue. We might see some very large bumps that are kind of circular that form a kind of V shape. The first time I saw this looking in the mirror, I got very worried because it looks like some form of medical condition or medical deformity. But they are actually a type of taste papillae known as circumvallate papillae. Each of us have about 7 to 12 of these circumvallate papillae, which isn't very much, but they house thousands and thousands of taste buds, enabling them to enhance our ability to taste and perceive different flavors in the food we eat. Now, evolutionary speaking, they are thought to play a protective mechanism. If we eat something that is bitter, it signals to us that it could be something potentially toxic. Circumvallate papillae are also extremely important in producing saliva and for our digestive system, as they also house von Ebner's glands, named after Austrian histologist Victor von Ebner. These glands pump up little biological machines that play a very important role in our digestive system, as they help break down food when it is in our mouth. Then we have the foliate papillae. Their main purpose is to help us perceive taste, as they house hundreds of taste buds. Finally, we get to the filiform papillae, which doesn't actually have any taste buds, but they still play a very important role. Their rough thread-like texture gives our tongue that tactile sensation, which helps us manipulate food when it's in our mouth. So each papillae plays different roles. But how do we taste? Like really, how do we distinguish one taste from another? When foods and drinks come into contact with our taste buds, they will trigger a biochemical reaction, which then produces an electrical signal. These electrical signals then travel to our gustatory nerve fibers, also known as our taste nerves. Scientists have discovered that different subsets of taste receptor cells and taste nerves get activated based on the quality of the taste, which enables us to distinguish between the quality of taste between the same food from different restaurants or shops. Once our taste nerve sends out the electrical signal, it then passes through 3 cranial nerves: the facial nerve, the glossopharyngeal nerve, and the vagus nerve to be able to reach the solitary nucleus within the brainstem. And it is here that the initial processing and integration of taste information actually happens. These taste signals then get relayed to our thalamus, which then projects the information of taste to our gustatory cortex, the main area where the majority of the information of taste gets processed and interpreted, allowing us to distinguish and perceive different tastes, the quality of the taste, and different types of flavors. Think of it like someone sending you a personalized message. The message has to get written and go through the mailing process, which starts at the post office. Then the postman or woman will pick up the message and deliver it straight to you, where you are the brain that interprets this message. Obviously, we know that anything related to neurochemical signaling is much more complicated than what we just saw, and there are many more complex interactions that are actually occurring. But that essentially is the simplest explanation, or at least the simplest I can come up with. Let me know if you have a better one. So how does being in a plane up in the air make food taste worse or more bland? As the plane ascends up into the sky, the air pressures in the surrounding environments drops fairly quickly, and so does the oxygen level. Planes generally fly and hover anywhere between 9,000 to 12,000 meters above sea level. At this altitude, the air pressure and oxygen levels are so low that it would be very difficult for us to breathe. In fact, it might merely be impossible. To put this into perspective, this would be worse than trying to breathe in the death zone of Mount Everest, which sits at around 8,000 meters above sea level. The oxygen levels at this altitude makes up only a third of the level of oxygen on the ground. This is so dangerously low that we would likely suffer from hypoxia and die if we don't have oxygen tanks. So a plane cabin is pressurized to combat this and to make flying a more comfortable and safer experience for its passengers. The air pressure within a plane cabin sits around 75 to 80 kilopascals, whereas the pressure on the ground sits around 101.3 kilopascals. And this difference in air pressure can actually affect our taste buds and our sense of smell. If you might not have guessed it already, our sense of smell is highly linked to our sense of taste. A quick little experiment we can do at home is to eat food that give off a lot of odor, like a well-cooked chili con carne or a very nice broth, but do it with our nose closed like this. You may find out that your ability to taste different flavors is not as strong. This is because our sense of smell allows us to interpret the different odors our food is giving off, and that provides some of the information that our brain uses to enhance the flavors that we get. Picture the last time you were sick and you had a blocked nose. You might recall that your ability to taste different flavors was not as strong. This applies to being in a plane. As the plane ascends up into the sky, the nasal passages in some people will become congested due to the change in air pressure. Congestion in our nose makes it much harder for our brain to interpret the different flavors and tastes that we are experiencing because it interferes with the olfactory system. Unfortunately, the lower air pressure in a plane cabin also affects our sense of taste directly. This experiment, where participants were put into a simulated high altitude experiments inside a hypobaric chamber which almost mimicked the environment of an actual plane at 10,000 meters above sea level, found that people tended to have a preference for sweeter and saltier food options. On top of the low air pressure, plane cabins can be surprisingly dry. Some studies have suggested that some planes at an altitude of 10,000 meters above sea level can be extraordinarily low in humidity levels. To put this into perspective, the Saharan Desert, very hot and dry place, averages around 25% in terms of humidity level. Some planes can have a humidity level as low as 12%. The dry air in a plane cabin, as you can imagine, will make both our nose and mouth very dry. And this is not good because saliva plays a very important role in our digestion as it disperses the food molecules across our tongue so that more taste buds get activated. With such a low humidity level, it's like a drought happening in our mouth. Like, seriously, our mouth is probably drier than the Saharan Desert. Salty! So that brings up my question. Why don't we just make the air pressure within a plane cabin the same as the air pressure on the ground? Planes are designed to withstand the difference in air pressure between the inside and the outside of the plane, but the windows and the doors of a plane are designed and engineered to withstand lower pressures on the inside. If the pressure on the inside is too high, it could damage the integrity of these doors and windows and they could fall apart. And like we see in the movies, we might get sucked out. But at least we'll go skydiving, right? Other reasons could be cost and complexity. For a plane to withstand the air pressure at sea level, it would need to be designed with stronger materials so that it can hold its structural integrity during flight and doesn't fall apart. And this will definitely skyrocket the cost of making planes. So unfortunately, we have to suck up with the low air pressure of the plane for our own safety and so that the plane doesn't get completely obliterated. Anyways, low air pressure and low humidity levels aren't the only factors that affect our taste during a plane flight. There is also noise and temperature. In fact, some studies have shown that some people associate certain noises or sounds with specific tastes. This phenomenon is known as cross-modal correspondence because we are associating the input from one sense, in this case noise, with another, taste. This is why a lot of restaurants play music whilst you eat. It's to enhance the flavors, good sir, and for a gravitas. But it can also be negative. An infamous study by experimental psychologist Charles Spence, where he blasted blistering decibels into the ears of his volunteers and observed how they responded to how sweet or salty a food was, found that high decibel noises, like the noise in a plane, decreases our sensitivity to sweet and saltiness, but it doesn't affect the taste of umami, which is extremely prevalent in tomato juice. I know, it sounds disgusting, but Charles Spence found that 27% of all beverage orders were accounted by tomato juice. Sadly, this is something for the most part out of our control. When a plane is flying, it encounters a lot of turbulence and air resistance, and this makes a profound amount of noise when it interacts with the wings and the other components of the plane. If only we could tell the turbulence and the air resistance to go away with a song. You know, like the Go Away Rain dance, if you ever done that. The turbulence experienced by a plane can cause the airframe of the plane to vibrate a lot, and this does create quite a bit of noise. On top of that, planes have auxiliary systems that keep it functioning, and those two also make quite a bit of noise. For instance, planes have air conditioning systems, air filtration systems, and hydraulic systems, all of which require mechanical movements to function. So how is it that loud noise affects our sense of taste? I mean, they are different sensory systems after all, right? Our auditory systems are interconnected with our sense of taste as well. Another major influence could be this concept that scientists have termed cognitive overload. Planes make a profound amount of noise, and combining that with the different tastes and flavors our food has, the different environments within the plane, sometimes our brain won't have enough resources to be able to process all the taste sensations on top of everything else. Just like having less tabs open on your phone, your brain can function and process information much more quickly and efficiently when there is less unknown sensory input from the surrounding environment. So we can all see that the bland and boring taste of foods in airplanes aren't the fault of the chef or the flight attendant. And for the most part, the factors that do influence our sense of taste in airplanes are out of our control. So before you go grilling the flight attendant or the chef during your next flight for your holiday, just remember, it's not their fault. Just blame Mother Nature. Thank you all for sticking until the end of the video. I hope you learned something new. If you have any comments on today's topic, make sure to chuck it down in the comment section below. Don't forget to give this channel a subscribe if you've learned something new and you enjoy and want to learn more about how science influences us every day. As always, I appreciate you all. We are the ones who wonder. See you guys next time.